Hi everyone. Is the audio video everything is clear? Let me know. Okay. So let's start. Now in this lecture we will study three things we are going to study. So we will study so these are the topics. So we will study common sub-expression analysis. Okay. So I can say common sub-expression elimination. Common sub-expression elimination. So this in short we will call it as CSE, common sub-expression elimination. Okay, so this is the short form. Next we will study what is copy propagation. Okay, so what is this copy propagation? In short we can call it CP, copy propagation. Okay, we will also study what is I can say available expression analysis. So this available expression analysis. Okay, so you can notice this available expression analysis, we use this in these two. Okay, so this is actually, these are the applications. Okay, so available expression analysis has these applications. So these are the applications, these are the applications of available expression analysis. Okay, AEA. Okay, so I can say available expression analysis. In short we will call it available expression analysis. Okay, so these are the topics for today, and also we will see constant propagation analysis. These two things we are going to see. Okay, so these are the topics for today's class: constant propagation analysis. This is constant propagation analysis. Okay, anyway, so these are the topics. Let's start. So first we will see what is the common sub expression elimination. Okay, so this we have already seen, correct? So today's class only these topics will be there. Okay, Ashe, only these topics will be there. So this we have already seen, common sub expression elimination. What it means that if you have computed some expression, then you do not have to compute it again. What you can do, you can use it. Okay, so for example, you can notice that if I'm doing like this, a equal to b plus c. Okay, and then let's assume some statements are there, and let's assume here I have something called d equal to b plus c. So you can notice that, okay, at this point you can notice, at this point I have computed this expression, this b plus c I have done. Okay, so this expression, I can say this expression, what is the expression? That is b plus c. This expression I have computed here. At this point of time I have computed b plus c, and this value I have stored in this variable a. Okay, so this expression I have computed, and the value I have put in the variable a. Okay, now you can notice that here again I am, okay, I have b plus c. I again have to do b plus c. So what I can do, I don't have to compute again. Okay, I do not have to calculate this b plus c again. What I can do, I don't have to calculate, because I know that this b plus c, this value is already present in the variable a. So what I can do, I can replace this b plus c with the variable a. Okay, so this is called common sub expression elimination. You can notice this and this, these are common sub expressions. Okay, so these expressions are same, so these expressions are common sub expressions. Okay, now you can notice, so we don't want to calculate again. What we can do, this b plus c we can replace with the variable a, because this variable a holds the value that is b plus c. Okay, so this value, this b plus c, this value is already present in variable a. Okay, so this is stored in variable a. So I can say this is stored in variable a. Okay, so I can directly use this variable a. Now what is the condition? The condition is that here, okay, I should not change the variable a. Okay, here at this point I should not change a, b, c, any of them I should not change. I should not change a, I should not change b, I should not change c. So here remember, here a comma b comma c should not be defined. Okay, should not change, or I can say should not define. Okay, so we should not define these, okay, in this area. Okay, so this is the point. Now you can notice, so basically this expression, so this is common sub expression. Okay, so this is called common sub expression. So this is called common sub expression. Now what we can do in this area, remember that these values v1 a, okay, they should not change between these two. Okay, so in this area I can say that these values should not change. Okay, in this area these values should not change. Then what I can do, I don't have to compute again, I don't have to calculate again. What I can do, I can directly use this variable v here, I can directly use. So what I can say, so okay, so this is what I can do. Now this is called, basically this is eliminating, okay, useless recalculation. So this is called common sub expression elimination. Okay, now let's see. So for example, all these things I have already covered in the previous videos. So okay, but let's see what is this. So for example, here this a plus b, you don't have to calculate again. Okay, what you can do, this is already available in this variable temp4. Now you can notice that, okay, in this area a, b comma temp4, these are not changing. Okay, so in this area these are not changing. So what I can do, I can replace this a plus b with temp4. Okay, so with the temp4 I can replace. So this is the point. So this is the point you can notice. So I can replace with temp4. Similarly, remember, okay, is this common sub expression elimination? This is also common sub expression elimination. Remember, common sub expression elimination, what is this? This is simply like this. Okay, you have something here alpha and you have something here, okay, and here you have something called, okay, again you have gamma and here you have beta. Okay, so in this type of situation, okay, and here nothing should change, alpha comma beta should not change. Okay, should not change. Okay, so in this area they should not change. Okay, then in that case what I can say, I can replace this beta with this alpha, because remember this beta is already available in alpha, this beta is stored in alpha. So I can say this beta, this is stored in alpha. Okay, so what I can do, I can replace this beta with alpha. Okay, so this is the point, because this beta is already stored in alpha, so I can replace this beta with this alpha. So this is your common sub expression elimination. Now you can notice that this is also common sub expression elimination, because this 4 is stored in temp4. Okay, this 4 is already stored in temp 0. So okay, now what you can do, you can basically, okay, what you can do, okay, you can put temp 0 here. Okay, so this is also common sub expression elimination. Okay, this is also common sub expression elimination, but actually we don't do this. Okay, but anyway, the point is this is also common sub expression elimination. So you can notice this 4 is stored in temp 0. Okay, so you can notice here also we have 4. So you can notice this situation we have. Now what we can do, we can replace this 4 with temp 0. Okay, so this is what we can do. This is also common sub expression elimination. Okay, another example is, you can notice this temp4. Okay, so this temp4 is already stored in C. Okay, here also we have temp4. Okay, this is temp4, this is temp4. So in this situation also we can replace this temp4 with C. Okay, so this is also what we can do. So finally we are going to get this. So this is your common sub expression elimination. So now the next is copy propagation. So we have seen what is common sub expression elimination, this we have seen. Now the next topic we will see is what is copy propagation. What is copy propagation? Copy propagation is like this. Okay, so this is also very simple. Let us assume that you have a, okay, so let us assume that in this a you have variable b. Okay, so basically in this a basically you have variable b. Okay, now after some time let us assume that you have c equal to a plus d. Okay, now you can notice that, okay, so this a, and remember this value b is already stored in a. So what I can do, I can directly use this value b. So what I can do, I can replace this with b. Okay, this is called copy propagation. Okay, this type of optimization, this optimization is called copy propagation. And what is the condition? The condition is here a comma b should not change. Okay, they should not change. So they should not change. If, okay, then in that case I can do this. This is copy propagation. Okay, I hope this point is clear. So you can notice if we have this type of variable assignment v1, okay, so basically this v2 we have in v1, then in that case what we can do, okay, then what we can do, basically this v1 we can replace with v2. Okay, so this is your copy propagation. Okay, so for example, you can notice that this is your x, and this x you are using here and here. So what you can do, you can use directly this temp1, because remember in this area, in this area temp1 is not changing. Okay, in this area temp1 is not changing, x is not changing. So finally instead of this x, what I can do, I can put this temp1. Okay, so this is what I can do here. So finally I will get this. Okay, now similarly you can notice in this variable a I have temp3, so I can replace this variable a with the temp3. Okay, so this is what I can do. This is also copy propagation. Another example is, this is pointer. You can notice, okay, star temp1 is equal, so basically, okay, you can notice that in this star temp1 I have the value temp2. So what I can do, I can replace this star temp1 by temp2. Okay, so this is what I can do. Okay, so this is also copy propagation. So these are the examples of copy propagation. I hope these examples are clear. You can notice temp2 is available in temp6. So what I can do, I can replace this temp6 with the temp2. Okay, so this temp6 I can replace with the temp2. Okay, so this is your copy propagation and common subexpression elimination. My question is, okay, so can you find the difference between copy propagation and common subexpression elimination? Okay, this is my question. If you have this type of scenario, let us assume a equal to, okay, so let's assume you have a equal to b, and then let's assume you have something called, okay, c equal to a. Okay, this I am changing to a equal to b, and let's assume c equal to b. Then is it copy propagation or common subexpression elimination? What is this? Is this copy propagation? Is this copy propagation? What is this? Is it copy propagation or common subexpression elimination? So which type is this? Okay, so here this you can notice, this is copy propagation. Okay, so this is your copy propagation. So this is copy propagation. And what about this? If I okay, you can notice why this is copy propagation. This is copy propagation. Why? Because you can notice this value b is stored in a, and now you are replacing this with this a. Okay, so this type of situation is copy propagation. So you are replacing this a with this b. Okay, so this type of situation is your copy propagation situation. Now tell me, if I have this type of situation, okay, so let's assume I have b here, and then let's assume I have a here. Then what is this situation? Now this is common subexpression elimination. Okay, so this is now, okay, I can say this is your common subexpression elimination, because now you can notice this b you have, so this same expression you have, and this b is stored in a. So what you are doing, you are replacing this b with a. Okay, so this is your common subexpression elimination. So I hope the difference is clear. What is the difference between copy propagation and what is the difference between common subexpression elimination? Okay, so the difference is clear. Let me know. Now let's see. Okay, so okay, if you have this program, so local optimization, what that means? Local optimization means within a basic block. Local optimization means within a basic block. This is the definition of local optimization, within a basic block. So this is your basic block, you can notice. Okay, so if this is your basic block, then what is the optimization you can create? So you can create common subexpression elimination, because you have a star a star a. So you can notice that this a star a you have calculated here. When you are here, you have calculated this, and this is stored in b. Okay, so this you have stored in b. So what you can do, you can use b here. Okay, so this is what you can do here. Okay, this is your common subexpression elimination. Now tell me, okay, what is this? Can anyone tell me which optimization is this? Like here, what optimization I can create? Okay, in between these what optimization I can create? Just tell me this. My question is, this red one you can check. Okay, on this red one, what optimization you can create? So you can notice that b is available in c. Now you are replacing c with b. Now you are replacing this c with b. So this c you are replacing with b. This is called copy propagation. Okay, this is called copy propagation. I told you the difference between copy propagation and common subexpression elimination. Okay, is this difference clear to everyone? What is the difference between copy propagation and common subexpression elimination? The difference, remember, okay, note that this is the difference. Okay, so okay, note that this difference you note. So in common subexpression elimination and in copy propagation, what happens? In common sub-expression elimination, you have this type of situation. So this beta is stored, and after some time you have this gamma equal to beta. So basically what you do, okay, so this beta, you don't want this beta to compute again. You don't want to compute, you don't want to calculate this beta again. So what you can do, you can replace this beta with alpha. This is called common sub-expression elimination. In copy propagation, what happens? In copy propagation, this type of situation happens, that you have this type of situation. Okay, so this so what you do, basically this type of situation happens, remember, in this, okay, and here this type of situation happens. Okay, so here this type of situation happens, and here this type of situation happens. Then in that case, what you do, you basically replace this alpha with the beta. Okay, this is your copy propagation. I hope the difference is clear to everyone. Okay, so now if the difference is clear, then you can just move on. So this is your copy propagation. Okay, so finally now you can apply common sub-expression elimination again. You can create, because b plus b. So what you can do, you can create common sub-expression elimination again. So this is what you are going to get. Okay, anyone has any doubt? Anyone has any doubt, let me know. Okay, so these are the optimizations. Now let's see the next topic. Now the next topic is available expression analysis. In short, we will call it AEA. Okay, this is what we are going to call it in short, AEA. What is available expression analysis? This is, okay, what are the applications? Remember, what are the applications of this? We will see what are the applications. So applications are, first, okay, so in the copy propagation, okay, so these are the applications of this. One is copy propagation, okay, and the second is common sub-expression elimination. Okay, so these are the two applications of this analysis. For this analysis, these are the applications. Now let us see what is this available expression analysis. The name itself is telling you that basically it is talking about available expression. Which expression is available? Which expression is available means computed. Available automatically. Okay, this available means computed. So which expression is computed? Available means computed. Okay, so let's see. So you can notice that consider here. Okay, just consider this program. Now tell me, if you are standing here, then which expressions are computed at this point of time? Okay, if you are standing here, let us assume that you are here. Okay, at this point which expressions, okay, at this point which expressions are available, which expressions are computed? Available means computed, you can notice. Okay, so basically which expressions are computed? You can notice x into y is computed, you can notice s plus t is computed, you can notice u by v is computed. Okay, so at this point of time these expressions are computed. Okay, at this point of time which are expressions are computed? At this point of time x into y is computed, at this point of time x into y is computed, s plus t is computed, and at this point of time x into y, s plus t, u by v, these are computed. Okay, yes or no? Is this clear to everyone? So which are the computed expression? Available expression means computed expression. So here these are the expression available, and here these are the expression available, and here these are the expression available. Okay, so what is the available expression? So the point is very simple. You are here, let us assume. Okay, let us assume you are here. Okay, then what are the available expression here? Available expression, what expressions are available here? Basically this is my question. Okay, what are the available expressions here? What expressions are available here? Can anyone tell me? You are here. Okay, in this program you are here. Okay, this is your point n. So what expressions are available? Expressions are available means, okay, you have computed them and they are available here. You have computed them, they are available here, means they are computed at some point of time before this instruction. Okay, they are computed. Okay, you are here. Now available expression means those expressions which are computed before this instruction is executed. Okay, so before this instruction is executed, what expressions you have computed? Okay, so these are called available expressions. Okay, so basically available expression means has the value of this expression already been computed? So this is important. So basically this expression you have, okay, x into y, what you will ask? So this is the question you are going to ask. This value x into y, have we computed this value? This value x into y, have we computed this value already? Means basically this value, okay, from somewhere have we computed this? So this is the point. Okay, this is your available expression. So now for example, and also again the same point that I told you in liveness analysis, also I told you this point. So let me tell this point again. Okay, remember, so let me tell this point again. So this point you can note that available expressions at statement n, this is your, let's assume this is your statement n, then tell me what do I mean by that, then tell me what do I mean by that. At available expressions at statement s, available expressions, available expressions, let me call it AE, okay, available expressions, AE, available expressions at s, what that means, available expressions at s, what that means, tell me. The same in the liveness analysis we have done, available expressions at s, that means just before s, yes or no, that again means just before s. So available expressions just before s, okay. So this is your, the same point, available expression at s, that means available expressions just before s, okay, just before s. So for example, tell me what are the available expressions here, okay. Let me give you this statement, a equal to b plus c. Now let me give you, okay, let's assume this is, okay, c plus d, and then let's assume, okay, you have b equal to or you can say maybe you have c equal to b plus c. Tell me what are, okay, tell me, first you tell me what are the available expressions here. Okay, so tell me what are the available expressions. So okay, here you have available expression is 0, this is your available expressions, okay, this is your available expressions. So what are the available expressions here? Available expressions here means, tell me what are the available expressions here, that is same as this, okay. So this and this both are same, correct, available expression at this statement. Now what are the available expressions here, what are the available expressions here? So b plus c, this is the available expression here, okay, correct. So b plus c is available. Now what is the available expression here? Can anyone tell me what is available expression here? You can notice here b plus c is available, okay, but now b is changing, we are changing b, so this b plus c is not available now. Remember, this b plus c is not available now. Now c plus d is available, now b plus c is not available, okay. So remember, this is the point. So for example, you have this, so now c plus d is available, now this is not available, here this is available, here this is available, okay. And what is available here? Here c plus d is available, b plus c is available, correct. So c plus d is available and b plus c is available. So is this clear to everyone? Okay, what are the available expression? Remember, available expression at a point, okay. For example, if I say that, okay, in the same question, if I say a equal to b plus c, and then you have b equal to c plus d, and then you have e equal to b plus c. So in this question, if I ask you what are the available expression here, then that is 5, because remember, available expression at any point, that means just before it, what are the available expression here? That is c plus d, okay. So sorry, just before it, okay, just before it means available expression just before it, so it means b plus c. And here what are the available expression? That is c plus d, okay, c plus d. And okay, what are the available expressions here? What are the available expressions here? That will be c plus d comma b plus c, okay. Is this clear? Anyone has any doubt in this? Okay, so the same point, b plus c is not available because b is updated. Yes, that is the reason, because b is updated, okay. So okay, this point is clear to everyone. Available expression at a point s, that automatically remember, okay. So available at, okay, so this is your s1, this is your s2, this is your s3. So remember this point I am telling you, okay, this point, that available at s, what that means, available at s2, what that means? That means just before, okay, available just before s2, correct, available just before s2, just before s2, correct or not? Okay, so this is the point, available just before s2 means you have to check here, okay. So this is your available just before s2. If anyone has any doubt, you let me know, okay. So this is your available expression analysis, okay. Now similarly you can check, for example, what are the available, okay, so this is your, let us assume, so you can notice here, for example, let's assume this is m and let's assume this is p. Then you can notice what is available of m. Can anyone tell me what is avail of m? What is avail of m? Avail of m, what is that? So that is 5, okay, that is 5, because avail of m means what is available here, that is avail of m. And what is avail of p? What is avail of p? Avail of p means that is x into y. Okay, that is x into y, correct? Because avail of p means just before p, means here what is available, here what is available, that is your avail of p, correct? Here what is available, so that is x into y. Now what is avail of n? That is x into y s plus t. And what is avail of this? I can say what is out avail, what is out avail of n? What is out avail of n? What is that? That is x into y s plus t and u divided by v. This is out avail of m. Okay, n, correct? Okay, is it clear? Is this clear? What if last equal to c plus b, b plus c? Okay, so let's take that also. So for example, now okay, Rajan is asking what if this type of statement we have, let's assume b equal to a plus b and let's assume c equal to a plus c. So tell me, Rajan, can you tell me, okay, what is available expression here? That is phi. Okay, and what is available expression here? What is available expression here? This is a plus b, because remember available expression here, what is that? That is a plus b. Okay, that is a plus b, correct? Now what is available expression here? What is available expression here? Tell me, what is the available expression here? Can anyone tell me? Can I say a plus c is available expression? This is my question. Can I say c, a plus b is available, but can I say a plus c is available? Can I say this? Can I say this? Is this correct? Basically, can I say is this available here? Tell me, is this a plus c available here? Means you have calculated a plus c. Is this available here? The answer is simply intuitively think. The answer is no. The answer is no. So this is not available. Remember, the answer is no. This is not available. Why? Why? Tell me why. Because you have computed a plus c and this is stored in, you have stored this as again c. See, just think like this. Okay, think like this. Think like this. Okay. So you have computed. So this is like you have computed a plus c. This a plus c, let's assume you put in some temporary variable t, and this temporary variable you put in c. Now you can notice, now a plus c is not available, correct? Now a plus c is not available, correct or not available? Yes. Is this clear, Rajan? Is it clear? So very intuitively you can think. Okay, so now a plus c is not available, so you can say a plus c is not available here. Okay, let me know. Very intuitively you can think. Actually there is nothing hard here. Okay, just think intuitively. Okay, so you can notice, because you have computed. Actually this happens, let me tell you, after some time I will tell you actually what happens. Actually what compiler does. Okay, so actually what compiler does, let me tell you, it does like this. Okay, so whenever something is computed, it is actually put in the temporary variable. Okay, whenever an expression is computed, okay, whenever an expression is computed, it is put in a temporary variable. It is put in a temporary variable. After some time we will see. Okay, I will tell you after some time, this I will tell you, but it is put in some temporary variable. For example, okay, you have this scenario. Let us assume b equal to a plus b and c equal to a plus c. Now you can notice that here when you compute this, then what compiler will do? Let me tell you what compiler will do. Compiler is going to do like this. Okay, so first compiler will compute this a plus c and it will put this in. So this a plus c will be computed and this, it's like this. Okay, so this a plus c will be computed and it is put in b, that is fine, but this b is put in t. Okay, or basically, okay, there is no problem here. You can compute, okay, or you can do like this. Either you can do like this or you can do like this. Okay, there is no problem. Okay, so this is either you can do like this or you can do like this. So the point is this. Okay, but anyway, let's do this. So you have computed a plus c, you have put in b, and now you have put this b in t. Now what you will do? Now this a plus c you have. Okay, this a plus c you have. So what you will do? You will replace this with t. But the point is here now a plus c is not available. Here a plus c not available. Yes or no? A plus c not available here. Correct or not? Not available here. Because why this is not available? Because c is changing. So here at this point of time a plus c is not available. Okay, is this clear? A plus b is definitely available. A plus b is definitely available because you are not changing a, you are not changing b, you are not changing a comma b, so that is available, right? A plus b is available. I told you, okay, that it is put in the temporary variable. Okay, whenever an expression is computed, whenever an expression is computed, it is put in a temporary variable. This is what I am trying to tell you. Okay, it is put in a temporary variable. Okay, is this point clear? Okay, so anyone has any doubt, you let me know. So for example, let me check. So what we can we create some more variation? Let me check. Okay, so anyway, yeah, I think the point is clear, right? The point should be clear that whenever an expression is computed, this we will see after some time. Okay, this we will see after this whole thing, this thing we will see after some time, don't worry. Okay, let's just see this. Okay, so tell me, available expression, this is your control flow graph. Okay, for this control flow graph, let us see this. Tell me, this expression b plus c, is it available here at this point? Is it available here? Tell me, is this available here? The answer is yes. Why? Because you can notice we are not changing b, we are not changing c, we are not changing b, we are not changing c, so b plus c is available here. Okay, is this clear to everyone? So you can notice b plus c is available here because we are not changing b, we are not changing c. Okay, so I can say that b plus c is available here. Correct or not? Okay, actually here one more interesting thing I want to tell you. Okay, so let me tell you, because from this point, whenever an expression is computed, it is put in a temporary variable. So one more example, let me tell you. Okay, let's assume this is the situation, and let's assume that a equal to, okay, let's assume a equal to d plus e, and let's assume that you have okay, so some maybe, okay, f equal to b plus c. So tell me, just tell me this point. Okay, can I say that this is available here? Can I say, is this available? Is this available here? Is this available here? Just tell me this point. Is this available here? Is this expression available? This is my point. Is this expression available here? So basically, are they common sub expression? This is my point. Are they common sub expression? Are they common sub expression? So tell me. And the answer is yes. The answer is yes, because remember I told you that whenever an expression is computed, it is put in a temporary variable. This is what actually what compiler does. So this is what is done. So the answer is, are they common sub expression? And the answer is yes. And the answer is yes, because remember what compiler does. I told you what compiler does. So what compiler does? What compiler does? Compiler will do something like this. Okay, so a plus c, and this in t he will put, okay, this compiler will put, or this expression basically is put in this, I can say, okay, this expression is put in a. So I can say this expression is computed, and this expression will be put, I can say, so this expression is computed and it is put in a. It is put in temporary variable. So this expression will be computed and it is put in a temporary variable. So actually this is put in a temporary variable. Now in this a you will put t. Now you can notice that still here a changing, but you can notice that b plus c. So this b plus c is already put in the t. So this b plus c is already available in t. Okay, so this a changing, that is fine. A changing, that is fine, but this b plus c, so this is actually replaced with the t. Okay, so this a changing, that is fine, but you can notice this b plus c, this is available already in temporary variable. So this is what I am telling you, that whenever an expression is computed, then this expression is put in temporary variable. So it's like this, it will put in temporary variable and then b equal to t. Okay, so like this. So whenever an expression is computed, it is put in a temporary variable. So this is what your compiler will do. Okay, so we will come back to this point, don't worry. After some time we will see this again. Okay, so okay, just tell me, this expression, is this available here? Okay, so the answer is yes. Is this available here? Answer is yes, because b comma c are not changing. You can notice So that is the point. Now tell me, b plus c is it available here? The answer again is yes, because you can notice b comma c are not changing in this path. Okay, in this path b comma c are not changing. Okay, so tell me, is this yes or no? B plus c, is it available here? B plus c, is it available here? Tell me, is it available here? B plus c, is it available here? Okay, just tell me this point. Let me remove it. So tell me, is b plus c available here? Yes or no? Okay, apply your thoughts. What are your thoughts? Just apply them. Okay, you think about it. Okay, just let me give me 2 minutes. Okay, you think about it. Okay, so tell me, what can you say? Is it available? The answer is no. The answer is no, because just think about it. Okay, just think about it. If your program, okay, here b comma c you have computed. Now just think about it. If your program, is it guaranteed that your program will go like this? Is it guaranteed? Is it guarantee? Is it a guarantee that your program will go like this? No. Okay, if your program goes like this, then what will happen? Okay, tell me, there is no guarantee that your program will go like this. If your program go like this, then what will happen? You can notice here b is changing. Okay, you can notice here b is changing. So that is the reason, because b is changing, so the answer is no. Because here you notice this b is changing here. Yes or no? Yes or no? So this b is changing here. Okay, so if your program goes like this, okay, on this flow, I can say that on this flow, if your program has this flow, so let's assume the program makes this flow. Let me do. If your program has this flow, okay, if your program has, if this is the execution flow, okay, on this path, focus on this path. On this path, p changes, b changes, b change. Correct? Is this clear to everyone? Tell me. On this path, b changes. Okay. So I can say that expression is not available. Is this clear? Because b is changing, right? Here b is changing. B is changing. Okay, so that is the reason b plus c, b is changing. So that is the reason I can say here it is not available. Is this point clear to everyone? So remember, available means on all the paths it must be available. Okay, so this is a point, this is a note, because available means basically on all the paths it must be available. Okay, so I hope this point is clear to everyone. So is this clear? So remember, available means, okay, I can say expression is available. I can say, okay, so, okay, for example, let us assume that, okay, let's assume that you have computed expression here. Okay, so at this point P, let's assume you computed it here. At this point P, let's assume you computed a comma b, a plus b. Let's assume at this point you computed a plus b. Now here you have, let's assume c equal to a plus b. Now when can I say that it is available? Okay, when can I say that it is available? Means this a plus b, is it available here? It is available here when on all the paths. Okay, in every path. Remember, in every path. Okay, so remember, on every path this must be available. Okay, on every path they must not change. So this is the point. Yes or no? So I can say on every path. On every path this must happen, which a comma b should not change, should not change on any path. Okay, I can say on any path. Okay, I can say for every path I'm saying on any path, whatever path you take, whatever path you take. Okay, whatever path you take, I can say whatever path you take, this should not change. Whatever path, whatever p to q path you take, okay, this a comma b should not change. Is this clear? Tell me. This is quite intuitive, yes or no? This is quite intuitive. I will tell you the difference between liveness analysis and available expression analysis. You don't worry about liveness analysis, that is a different analysis. Liveness analysis is different, available expression analysis is different, both are different. I will tell you what are the differences, so do not worry about these things. Okay, don't worry. Okay, so just focus on this. Did you understand this? Is there anyone who did not understand this? Okay, did you understand why this is not available, why this b plus c is not available here? Did you understand this? Okay, so this point you have to understand, that this is not available because on some path it is changing. If it is changing on some path, then it is not available. Okay, so let's see another example. Tell me, is this yes or no? Is this yes or no? So this is simply no. Okay, this is simply no because here b is changing. Okay, here you can notice b is changing. And what about this? Okay, what about here? Can anyone tell me? Here it is, okay, here it is available or not? Okay, just tell me. This is a very interesting question. So tell me, here it is available or not? At this point, at this point, at this point it is available or not? At this point, tell me. Can anyone tell me, is this available or not? Okay, so tell me, at this point is it available or not? The answer is no. Why answer is no? Why answer is no? Because of this loop. Because of this loop. Don't forget about this loop. Okay, the answer is no because of this loop. Okay, because you can notice, if you are here, now you can notice that because of this loop b will change. Because of this loop b will change. So we cannot say that here b plus c is available. Okay, are you getting this point? At least one path I can give you where b will change. I can give you at least one path where b will change. For example, let's assume this is path number 1. Let's assume, okay, this is path number 2. Then you can notice on path, I can say that on path, if you take this path 1 and then you take 2. Okay, first you take 1, then you take 2. Okay, so on this path 1, okay, then take 2. Okay, so then again you take 2. So you can notice b changes. Okay, is it clear? All the variations I am taking. Okay, you can notice all the variations I am taking. Is this point clear? So remember, this is what I am telling you. On whatever path you take, whatever path you take, they should not change. Okay, they should not change. In this situation, I will say that this is available. Okay, if this situation happens, then what I will say? Then I will say that this is available. Okay, in this situation I can say. So whatever path you take, they should not change. So don't forget about this loop. Okay, so don't forget about this loop. Many students will make mistake here. Don't forget about this loop. Okay, tell me, what about here? Here it is available, there is no problem. Here it is available. You can notice whatever path you take, here a plus c is available. And okay, here also a plus c is available, because you can notice if you go like this, a comma c are not changing. If you go like this, a comma c are not changing. Whether you go like this, whether you go like this, a comma c are not changing. Okay, so this is the point. Whatever way you go, they are not changing. So what is the point? This is the point. Okay, so remember, this is the point, because if you go like this or if you go like this, okay, you can notice here also a comma c not change. Okay, and here also a comma c not changed. So every variation I have taken. If anyone has any doubt, you let me know. Anyone has any doubt? Okay, so now let's see how can we eliminate the okay, use of available expression now means basically common sub expression elimination. Okay, so let's see this. A plus c is available here, you already know a plus c is available. So what you can do, you can replace this a plus c with f. Okay, so this is what you can do. Okay, so just replace this a plus c with f. This is your common sub expression elimination. Okay, similarly a plus c is available here. Can you notice here also a plus c is available. A plus c is available. Okay, a plus c is available. So what I can do, I can make this a plus c, I can replace this a plus c with f. I can replace this a plus c with f. Okay, because you can notice a plus c is available, you already know. So that is the reason this is how we can do. Okay, is this clear or anyone has any doubt? Okay, so like this you can do. Next, this is another type of question. Some expressions are given and numbers are given to you. For example, this expression x plus y, the number is 1, I less than n, the number is 2, I plus c, number is 3, x equal to 0, okay, the number is 4. Okay, so these are the expressions, and for these expressions these are the numbers that are given to you. And the question basically is asking, okay, so you have to give what are the available expressions. Okay, you have to tell what are the available expressions. What are the available expressions? At each point, what are the available expressions? Okay, at each white point, what are available expressions? Okay, so tell me what is the answer? Very simple. Here what is available? Initially nothing is available, so 0 0 0 0. Okay, 1 2 3 4. So what I can say, if available, I can say if available write 0. If available, I can say if available, then write 0. If not available, then if available, then write 1. If available, then write 1. If not available, then write 0. If not available, then write 0. Okay, so this is what you have to do. So tell me what is the answer. So now you can check it out. So initially everything is 0 0 0. Now here, okay, at this point what is available? X plus y is available, x equal 0, so that is available. So you can notice this is available, this is available. Okay, and what is available here? You can notice on every path they must be available, but you can notice here x comma b are changing. Here we are changing x, here, so okay, we are changing x. Okay, here you can notice, can anyone tell me what is available here? Just tell me this point. Okay, what is available here? Can anyone tell me? Anyone want to tell me what is available here? So you can notice what is available here. Here what is available? That is 1 0 0 0. Okay, and what is available here? Okay, so wait. Okay, so this is 1 0 0 0, and here what is available? That is 1 0 0. Okay, so here also this is available, right? X equal to 0. This expression is available here. This expression is also available here, right? So I can say that this expression is also available here. Is x equal to 0? So okay, if it whether it's true or whether it is false. So this is the true branch. So okay, so this will be actually available here. Okay, what is available here? So you can notice now x, okay, you are changing x. So okay, at this point what will be available? Because remember you are changing x. Because you are changing x here, so what I can say, I can see here, okay, here everything is 0 0 0 0. Okay, and what about this point? What about this point? Okay, so at this point what will be available? At this point again 1 0 0 0. Okay, and you can, so this is 1 0 0 0. Now next, so this is, now here at this point what is available? X plus y, so that is 1, and okay, so only this is available. Okay, because remember, on all the paths they must be available. At this point you can notice, at this point, why this is not available. See, here this will be available, but here why this is not available, because on all the paths they must be available. You can notice on this path x equal to 0 is not available. Okay, you can notice on this path, notice on this path x equal to 0 is not available. Okay, so remember, because on this path this is not available. Okay, next what you can do. So finally, now this is available. So this is 1100, 1100, and finally what is available here? That is also 1100, and what is available here? So here I can say that, okay, so c comma I are changing, nothing else is changing, so that will be 1 1. Okay, so x plus y is available, and you can notice, okay, I less than n is available. And this x plus y, okay, so that is available. I plus c, that is not available. I plus c is not available. Okay, so that is 0 0, 1100, 1100. Okay, anyone has any doubt, you let me know. Okay, so like this you can do. Okay, so at each point what are the available expressions, you can very easily find. Okay, now another question, for example, one question that I want to ask you. Okay, so let me ask you that point. If you have this type of situation, okay, then you can notice definitely x into y is available, correct? Yes or no? So you know that, okay, here you have computed, so let's assume this path is there, so x into y is available here, x into y you have computed here, x into y you have computed here. Okay, so x into y is computed here, x into y is computed here, x into y is computed here. Now tell me which x into y I should use here. So this is the question, why compiler puts computed expression in temporary variable. Why compiler puts computed expression in temporary variable. Okay, so this is the question, why compiler puts temporary variable in computed expression in temporary variable. Can anyone tell me what is the answer? What should be the answer? Let me tell you what is the answer. Let me tell you, because just think about it. Okay, just think about it. Let us assume that here you have a equal to b plus c. Okay, and let us assume here you have okay, d equal to b plus c, and here you have, okay, just think about it and tell me, and here you have e equal to b plus c. Okay, so these three things you have, and then this is coming, this is coming, this is coming, and here you have, let's assume f equal to b plus c. So tell me, I know that b plus c is computed. Okay, so what should I replace this? What should I put here? Should I put a? Should I put d? Should I put e? Can anyone tell me? What should I put here? Can anyone tell me? This is my question. What should I put here? Anyone? So you can notice that, okay, let us assume here you have computed, you know that b plus c is computed, b plus c you have computed. Okay, whether you go like this, b plus c is computed, whether you go like this, b plus c is computed, whether you go like this, b plus c is computed. So here at this point b plus c is computed. Okay, my question is, what should I do? This b plus c, what should I replace? I should replace this with a or b or d or e. What should I do? This is my question. So here what we are going to do, remember, the answer is like this. The compiler will do something like this. What compiler will do? Compiler will actually do like this. So because b plus c is available, you know b plus c is available, so here you will put t. Okay, here you will put t, and this b plus c you will put in t. What you will do? You will put this b plus c in t. So this is what you are going to do. Okay, so this b plus c you are going to put in t. Okay, so remember, in t you are going to put b plus c. Okay, in t you are going to put b plus c, on t you are going to put b plus c, and then what you are going to do, this b plus c you are going to remove with t. Okay, so this is the idea. Is this idea clear to everyone? So why compiler puts computed expression in a temporary variable? This reason clear to everyone? Because whether, okay, if you come from this path, then also b plus c is computed. If you come from this path, b plus c is computed. If you come from this path, b plus c is computed. Okay, so here b plus c is definitely computed, but what should I do? This b plus c, should I replace with a or d or e? What should I do? Okay, so what should I do? Very simple. This b plus c I compute and I put it in t. Okay, this value I will put it in t. This b plus c I will put it in t. This b plus c I will put it in t, and then what I'm going to do, a equal to t. So this t I'm going to put in a, okay, this t I'm going to put in d, this t I'm going to put in e, and finally I'm going to put t here. Okay, so this is the solution. I hope you like it. Okay, did you like this solution? Did you like it? This solution, did you like it? Quite good, right? Yes or no? Okay, so tell me. Okay, now tell me. So this is the idea. So that is the reason we do like this. Okay, now similarly compiler, what compiler is going to do, compiler again is going to do like this. Okay, so compiler, what it will do, this x plus y will be removed from here. Okay, this x plus y will be removed from here, this x plus y will be removed from here, and what the compiler is going to do, compiler is going to create a temporary variable. Okay, a temporary variable will be created. So let's create some t2. Okay, let's create some temporary variable. Okay, let me create temporary variable temp. In that temp I am going to put x into y, and then here I am going to print temp. Similarly here also, here I am going to put temp, and similarly here also I am going to put temp. And remember, in this temp I am going to put x into y, in this temp I am going to put x into y. Okay, and finally what I am going to do, this x plus y I will replace with the temp, this. Okay, so this I will replace with the temp. Is this clear to everyone? Anyone has any doubt in this? Okay, so this is a very simple point. Okay, so this is what my question is, why compiler puts computed expression in a temporary variable? Okay, so this is the reason, very simple reason. So whatever expression you compute, that will be put in a temporary variable. Okay, like this. So like this you can do. So okay, now, so available expression analysis, this is a forward data analysis. Okay, this is a forward because we are going in the forward direction. Okay, information from the past instruction must be propagated to the next instruction. Okay, so this is a forward analysis. Now next, what is the next point? What is the difference? Okay, all the differences we will see after some time. Okay, so don't worry about it. The difference of live variable liveness analysis and available expression analysis we will see after some time. Okay, so you can notice that just like liveness analysis, every instruction has effect, every instruction will affect the available expression, correct? Okay, so yes or no, every instruction will, okay, will, for example, here you notice, okay, this example you take, this is a very nice example. Okay, so tell me, what about here? You can notice here nothing is available. Okay, so now this expression, what it will do, it will generate a into b, correct or not? It will generate a into b, this expression will be generated. So I can say here a into b is generated. Okay, so here this is available expression, this will generate d plus 1, so this is also available expression. You can notice a comma b is not changing, so this a comma b is also propagated. So you can notice this is propagated, this expression is propagated, and this is generated. Okay, so this is propagated, this expression is propagated, and this expression is generated, this expression is generated, correct? And similarly you can notice that this is also generated, this f. Okay, so finally this is the point. So you can notice every, okay, every instruction, what every instruction does, every instruction will affect. So basically it is like this, you have instruction, okay, this is your instruction, this is your instruction s, and this is your in. What are the, okay, what is this means? What this means? This means set of available expressions, set of available expressions. What is this? This means set of available expressions. Okay, set of available expressions before s, and what is this? What is this? Tell me. This is set of available expressions after s. Correct. So you have out of s, you have in of s. So can anyone tell me, okay, just few things, few very interesting things I want to ask. Okay, again here you have something called for each instruction. So remember, for each instruction, just okay, so for each instruction what we'll do, for each instruction what we are going to do, okay, we have for each instructions, for each instruction n, okay, if you have s, then what we have something called what is defined, what is generated by s, what is generated by s. What, okay, so this is generated by s, And we have something called what is killed by S. What expression is killed by S? We have something called in of S, and we have something called out of S. And in of S is same as available at S. Okay, so remember this, you already know. Out of S, I told you, out of S means set of available expression after S. In of S means set of available expression before S. What is this? This is okay, set of expressions. This is set of expressions. This is set of expressions generated by S. This is set of expressions generated by S. And what is this? This is set of expressions killed by S. Correct? This is set of expressions killed by S. Okay, so this is the point, generated. Now tell me, what expressions are generated by this and what expressions are killed by this? This is your statement S. Now tell me what expressions are generated and what expressions are killed. Let us assume that here you have something called, let us assume here A plus B is okay, and here let us assume C plus D is also there, and let's assume B plus E is also there. Okay, now tell me what is this? Out of S. This is my question. Out of S. What is out of S? Okay, so take this question. Tell me the answer. Quickly tell me the answer for this question. So what is the answer? What is out of S? This is your in of S. So this is your in of S. So in of S automatically means this is your available at S. Okay, so now what is out of S? This is what I am asking. So the answer is very simple. What is out of S? So the answer is what? So you can notice this will be generated. B plus C will be generated. Very good. There is no problem. B plus C will be generated. But now this will be killed. Everything which has A, this will be killed. This will be killed. Yes or no? This will be killed. C plus D will be there. B plus E will be there. So what instruction is killed by S? Can anyone tell me? This S will kill which instruction? So you can notice here, you can notice S kills. Which instruction S kills? S kills A plus B. Yes or no? S generates B plus C. S generates A B plus C. S kills A plus B. Correct or not? Yes or no? S will kill this because this, okay, you are okay, because you can notice you are changing A. You are changing A. So now this is not available. Now this expression is not available. So now S will kill, okay, A plus B. Is this point clear? Another point, another question let me ask. So let us consider this. Let us consider this. B equal to B plus C. What is out of S? Tell me. Quickly tell me. What is out of S? So what will be out of S here? This is your in of S. Let's assume this is given to you. This is your in of S. So it means this is your available expressions at S. My question is, what is out of S? Out of S is what? You can notice that. Again, you can notice everything. Okay, so this B plus C will be generated, but then it will be killed. This B plus C will be generated, but then it will be killed. Yes or no? B plus C will be generated, but then it will be killed. Okay, so you can notice that only C plus D is here. Because you can notice, I can say S kills. What S kills? S generates. First of all, tell me what S generates. S generates B plus C. And what S kills? What S kills? S kills A plus B, B plus C, and B plus E. Yes or no? So first it will generate. Yes, B plus C will be generated, but then it will be killed. So can you notice? S will generate B plus C, but then it will be killed by S. So S will kill A, okay, because B is changing, so this will be killed, this will be killed, and also this will be killed. So S generates B plus C, S kills A plus B, B plus C, and B plus E. Okay, is this clear? So is this point clear to everyone? Can you handle all these questions? For example, just tell me. Okay, just one more question you can take. So I think this point is clear, right? I think this point is clear. So I think there is no need for any question. So this is the point. An instruction makes an expression unavailable when it kills, okay, its current value. So you can check it out here. Okay, this example you check. Let us assume these are the expressions that are available initially. Now you can notice A equal to 7. Now because of this A, this will be killed. Okay, so this will kill A into B. Okay, so this will be killed. So this will be killed. Similarly C. Okay, so this will now this will be killed. Okay, similarly this will be killed, this will be killed. Both will be killed. Correct? So this is the point. Okay, So now you have something called what generated. Okay, what are the expressions that are generated and what are the expressions that are killed? Okay, so tell me, what are the expressions that are generated? Now this is what we want to check. Okay, this is what we want to check. Okay, so tell me, what are the expressions that are generated by x equal to 3? This x equal to 3, what it will generate? This instruction, what it will generate? This is my question. Okay, so let me ask you, this instruction x equal to 3, what it will kill and what it will generate? X equal to 3, what this is going to kill and what this is, and let us assume here these are the expressions that are let us assume the question is saying ex is the set of expressions in the program which contain occurrence of x. So let us assume ex. What ex means? This is set of expressions which, this is set of expressions which contain x, which contain x, which contain x. Okay, example x plus y, example, okay, x plus 1, something like this. Okay, so let's assume these are the expressions that are these are the expressions that are you can notice. Okay, and tell me what is generated by this and what is killed by this. So you can notice this. Okay, what this will generate? This will generate, okay, so generate will be x equal to 3. This, okay, so, sorry, actually nothing will be generated, actually, sorry for that, because this is not expression, you can notice. So nothing will be generated, nothing will be generated, because you can notice this is not expression, so nothing will be generated. But what is killed? This ex will be killed. Okay, all these things that they contain, okay, so that will be killed. Correct or not? Yes or no? Agree? Anyone has any doubt? You can notice this expression, this instruction as this will generate nothing. There is nothing to generate, because you cannot, there is nothing to generate here. But you can notice this will kill all these things, ex. For example, this s will kill this. Okay, so these will be killed. Now similarly, print x plus 1, what it will do? Tell me. This print x plus 1. So it will generate. What it will generate? It will generate x plus 1. This will be generated. Okay, and what it will kill? It will kill nothing. There is nothing to kill here. Okay, it will not kill anything. So this is the point. Now similarly, x equal to x plus y, what it will generate, what it will kill? So tell me, x equal to x plus y, what it will generate and what it will kill? So what it will generate? What this s will generate? S will generate x plus y, and what it will kill? What it will kill? It will kill this x plus y also, ex also. It will kill ex also and this x plus y also. Remember, this x plus y will be generated, but after that it will be killed. So note, here you can note, okay, s generates x plus y, s generates x plus y, then kills it. Then kills it. Yes or no? So s will generate this and then it will kill it. Correct or not? Yes or no? So it will kill. So it will actually kill these things. So basically this ex also will be killed and this x plus y also will be killed. So actually here I should write that this ex also will be killed and this x plus y also will be killed. Okay. So both these things will be killed. Now let us see. So for example, this is your y plus 1. This will be generated. So you can just add it. Okay. This will be generated. So you can just add in this. Similarly, this, okay, this will be killed. This x plus 1 will be killed. Okay. From this instruction, this x plus 1 will be killed. Let us see another example. Okay. This example you take. This example you take. Here x plus 1, y plus 1. Now what will happen? Is okay, you can notice this example here, x plus 1, y plus 1. Okay, so you can notice this x plus 1. Okay, so just notice this. Now you can notice this x plus y will be generated. This x plus y will be generated, but after that it will be killed. Correct or not? See, this will be killed and this x plus y will be killed. So this is what I am saying. I am saying that x plus y also will be killed. Correct or not? So actually what will be killed? The killed will be actually x plus y also will be killed. Okay, so this x plus y will be generated and after that, because of this x, it will be killed. Okay, so This is the point. Now, can anyone tell me if you have, okay, so from this whole explanation, what can you say about out, how can you find, okay, this is the another question. How can you find what is out of n? What is out of n? Find out of n. Okay, so tell me, how will you find out of n? If you have this instruction n, then how will you find out of n? Tell me. If this is your instruction, then how will you find out of n? So what is that? So you can notice out of n. What is that? Okay, very simple. Out of n, that will be what? So first you generate and then you kill. At last you have to, okay, kill. Okay, so first what you will do? Okay, what is coming? What is coming? Okay, in of n, what is coming? Union with what is generated? What is generated? And then finally you kill. What are killed? What are killed? Okay, so this is your out of n. Is this clear to everyone? Okay, is this clear to everyone? Because remember, this is what we are doing, yes or no? This is what we are doing, because you can notice x equal to x plus 1, x plus y, and let's assume here you have y plus 1. Then what is this? This is your y, this is your out of n. So what is this? So what you do here, actually what we do here, so this is the point. So you can notice here, in of n, that is y plus 1, in of n. So you can notice, sorry, in of n is, let's assume, x plus 1, y plus 1. So this is your in of n, x plus 1, y plus 1. This is the in of n, x plus 1, y plus 1. And you can notice what is generated by n. What is generated by n? X plus y is generated by n. And what is killed by n? Everything that contains x. Anything that contains x. Any expression that contains x. Yes or no? Any expression containing x. Any expression containing x. Correct or not? Yes or no? Any expression containing x will be killed. Now what you do? Now very simple. So finally I can say out of n, that is what? So this and this is already available. This is also generated. So this is already available. So this is in and this is generated. And then what you do? So finally I can say x plus 1, okay, y plus 1. Union with x plus y. Okay, x plus y. And from this, first you have generated, now you kill it. Now you kill x plus 1 and you kill x plus y, because kill everything that contains x. Okay, so finally answer will be what? Answer will be y plus 1. Okay, so this is the whole idea. I hope this is clear. Anyone has any doubt? Let me know. Anyone has any doubt? Is there anyone who has any doubt? So very simple, because remember, first you generate, then you kill. So whatever is coming, so I can say out of n. What is that? What is the incoming? Union. What are you generating? What is generated by n? And finally, what is killed by n? Okay, so you can notice, and also you can notice, note, if instruction, I can say if instruction n defines variable x, then what is kill of x? What is kill of n? That is set of all expressions containing x. Set of all expressions containing x. Okay, so this is the equation that you will get. Okay, this is how you can find the out. Okay, now similar, so this is how you can do. Okay, so I hope this point is clear. Now how can you find in? This is the question. Okay, we have found out, but how to find in? How to find in of statement? How to find in of statement? This is the question. Okay, we have already found out. Okay, out we have found, but how to find in? Let me give you example. Okay, so consider this example and you tell me. So for example, let us assume you have here a equal to b plus c. Okay, and let us assume here you have c, let us assume here you have something called d equal to b plus c. Okay, and let us assume here you have b equal to let's assume d plus b equal to e plus f. Okay, just tell me. Okay, now tell me, what can you say? what is the in of s? This is my question. What is in of s? This is your s. Now what is in of s? Find in of s. Can anyone tell me what is in of s? From this example, what is in of s? What is in of s? Tell me. For this instruction, what is in of s? What is in of s? So the answer is what? You can notice that b plus c is not c. Okay, what is in of s? Means here at this point, what is in of s? So this is your in of s. You can notice, correct? So okay, remember this is your in of s. Now I am asking what is in of s. You can notice, okay, can I say b plus c? No, because here you can notice if you come from this side, then b plus c is not available. If you come from this side, then b plus c is not available. So remember, b plus c is not available. Okay, b plus c is not available. Okay, and what about e plus f? So b plus c is not available because if you come from this side, then b plus c is available. If you come from this side, b plus c is computed, but if you come from this side, b plus c is not computed. E plus f is computed here, but e plus f is not computed here. So nothing. In of s is phi. Yes or no? In of s, that is phi. Why? Because you can notice, see, if you come from this side, then e plus f is not available. E plus f is not computed. If you come from this side, then b plus c is not computed. So here the answer will be phi. Can I give another example? Okay, so let us assume you have point here. Okay, so this is your point. Let's assume this is your instruction s. And now let me tell, okay, just tell me this. This is b plus c and e plus f. These are the instructions that are available here. And let's assume b plus c and e plus d. This is available here. And let's assume b plus c and e plus f is available here. B plus c, e plus f and g plus h. So now tell me what is in of s. Now find in of s. What is in of s? Tell me quickly. Use your intuition. Use your intuition. What are the expressions that are available? Yes, very good. Nafis, very good. Excellent. Yes, it means intersection. Very good. This is what you need to understand. This is what you need to understand. So what are available here? You can notice, if you come from this side, then these are available. If you come from this side, then these are available. If you come from this side, then these are available. Okay. Now you can notice that whether you come from here or here or here, b plus c is definitely available. B plus c is definitely available. But you can notice, if you come from here, then e plus f is not available. If you come from here, e plus d is not available. If you come from here, e plus d is not available. If you come from here, g plus h is not available. So the answer will be what? This. So, okay, can you find out basically now? Okay, now can you find what is in of s? So what will be in of s? Tell me. So tell me what will be in of s. If this is your, okay, this is your statement s. Let us assume this is point P1, this is point P2, this is point P3, and this is point P4. Okay, so these are the point P1, P2, P4. Okay, so these are the point. Then what is in of s? In of s is what? That is, tell me what is in of s? That is out of P1, this is your P1, this is your P2, this is your P3, this is your P4. So that will be what? That will be out of P1, intersection out of P2, intersection out of P3, intersection out of P4. Yes or no? So finally this equation you will get. So I can say that in of n, okay, where this n is point n. Okay, so this is your point n. Okay, so statement n, basically this is statement n. Okay, so I can say in of n, what is that? That is intersection of out of all the predecessors. Okay, out of all the predecessors. So this is a predecessor. Correct? Is this equation clear to everyone? This equation, did you understand? Did you understand this equation? So in is nothing but intersection of out of all the predecessors. Okay, out of all the predecessors. So finally I can say these are the two equations. Okay, so finally these are the two equations, remember. Okay, for any instruction n, what can you say? For any instruction n, what can you say? So you can say there is something called gen of n. These are computed expressions by n. These are computed expressions by n. Okay, there is something called kill of n. Okay, these are set of all expressions. This is set of all expressions containing the variable defined by n. Containing the variable defined by n. Okay, next point. Okay, so this is your, for any instruction n, you can say generate of n, kill of n, and then finally I can say that in of n, that is same as available at n, that is same as available at n, and that is same as avail at n. Okay, and what is in of n? In of n you can very easily find. What is that? That is in, okay, sorry, out of n. You can very easily find out of n. So okay, and what is out of n? Out of n is what? Available just after n. Available just after n. And this means available just before n. This means available just before n. Okay, and what are the equations? What are the equations? So what is out of n? Out of n is very simple. That is in of n union what is generated by n, and then minus what is killed by n. Okay, this is your out of n equation. And what is in of n equation? This is intersection of out of all predecessors, where p is a predecessor. Okay, so these are the equations. This is your whole availability expression analysis. Can anyone tell me, did you get it? Did you understand? We have seen liveness analysis, we have seen availability expression analysis. Okay, I have made sure, basically I am making sure that you don't have to by heart any formula. Do not by heart any formula. Understand it, intuitively understand it. We have taken many examples. Okay, I have tried my best so that you do not have to by heart any formula. This formula that I am writing on the screen, this formula you can very easily understand. This is what I am trying. Okay, is this clear? No, Nafis, this is what I am saying. This is what I am saying. Available at statement S. What it means? Available at statement S. What it means? Can anyone tell me? Available at statement S. What this means? This means in of S. This means available just before S. Okay, this is what I am saying. You can notice this is what I am saying. Is this clear? Let me know. Did you get it? What we have seen so far, did you get it? So my question is this. Okay, so you can notice here, let us assume x plus 5 is coming from here and y minus 7 is available here. So this x plus 5 is available here, y minus 7 is available here. Then tell me what will be out of m? What will be out of m? That will be x plus y into, okay, x plus 5, because this is generated. This is generated, you can notice. Okay, so you can notice this is generated. This is generated by n. This is generated by m. Okay, this is generated by m, correct? Okay, and okay, what is killed by m? Everything that contains z, that is killed. So anyway, so the point is x plus 5, okay, x plus y. And similarly here you can notice that x minus 5 and y minus 7, okay, x into y. So this is generated. This is generated by n. This is generated by n. Okay, now you can notice you are coming from here, you are coming from here. Then intersection, what you have to do? You have to do intersection. Intersection of this, intersection of this. What is the intersection? That is x into y. So that is the point. So this is okay, you are coming from here, you are coming from here, then you have to do intersection, correct? Yes or no? So take intersection. Then you can notice, because of this statement, this is killed, this is killed. Okay, so finally this is empty. Now finally nothing. Okay, so is this clear? So this is the whole point. I hope all these points are clear to everyone. So here you are taking the intersection, remember. Okay, you are coming from here and you are coming from here and you take their intersection. Okay, so this is what you need to do. Okay, so hopefully all these points are clear. These two equations you can combine. Can you combine these two equations? Tell me, can you combine these two equations? You can combine them, right? Yes or no? Because you can notice here you are using in avail n, so this you can put here, this you can put here, correct? Yes or no? This you can put here. Okay, so what you can get, you will get out avail. Okay, out avail you will get in terms of this, sorry. Okay, what you can do, actually you know what is avail of n. What is avail of n? Avail of n, that means in of n. Or what is in of n? That is intersection of all the predecessors. That is intersection of all the predecessor, out of all the predecessors, out of all the p, which where p is a predecessor, where p is a predecessor. Okay, now what is out? This you already know. What is out? Predecessor. Now what is this out of p? This out of p, how can I write this out of p? This out of p I can very easily write like this. Okay, what is this out of p? This is, you can notice, this is in of p union what is generated by p. Okay, in of p union and what is killed by p. This is your available of n. So this is how you can merge these two equations. You can merge, because remember available of n means in of n, and finally you can get this. Okay, so this is how you can merge these two equations. And if there is no predecessor, this is my question, if there is no predecessor, then what can you say? If there is no predecessor, if there is no predecessor of statement n, then tell me what is avail of n. Okay, let's assume statement n also I am giving you. Okay, statement n also I am giving you. Statement n is this is the statement n, a equal to b plus c. Okay, so tell me what is avail of n. Can anyone tell me? If there is no predecessor, if there is no predecessor of a statement, this is your statement and there is no predecessor, means this is the first statement. Basically this is the first statement. This statement is the first statement. Okay, then what is avail of n? I told you again and again, I am telling you, avail of n simply means before this what is available. Before this what is available. Because there is no predecessor, so nothing is available. Because there is no predecessor, so nothing is available. Yes or no? So if there is no predecessor, then it means there is no available expression. So if there is no predecessor, then what you can say? Then you can say available. So if there is no predecessor of n, okay, so this is the point you can notice. If a predecessor of n is nothing, basically there is no predecessor of n, then available of n will be 5. Because remember I told you available of n automatically means in of n. In of n. Available at n automatically means available at n. Available at n. That means avail of n. That means avail of n. And that means available just before n. And that means in of n. Okay, so like this you can do. Okay, so anyway, so like this, this is very important. Remember, if something is, if expression is available, then what it means? It is coming from all the paths. Yes or no? Okay, note that. Okay, note that if expression, remember this is very important, so I am telling you, if expression E, okay, is available at point P, let's assume it is available. If it is available, P then it means what? Tell me. Then it means what? It means E is available. Okay, it means E is available on all the paths that are coming to P. Yes or no? E is available on all the paths. Yes or no? E is available on all the paths coming to P. On all the edges coming to P. On all the edges coming into P. Yes or no? Coming into P. So if you are saying that something is available here, this is your P. If you say that E is available, if you say then it means that whatever edge is coming on every edge, E must be available. E must be available here, E must be available here, E must be available here, E must be available here. Then we can say then E is available at P. Then E is available at P. Okay, but remember, so that is the point. So this is the point. You can notice expression is available at basic block only if it is available from all the predecessor of. Okay, so this is very important. So it should come from all the places. Okay, now let's see the difference. What is the difference? All the differences. Let's see all the difference. Liveness analysis versus what are the differences? Differences of available expression analysis, live variable analysis. Okay, so this means live variable analysis. What this means? This means live variable analysis. LVA, and this is your available expression analysis. Okay, so what are the differences? Did you find any difference? Can you tell me? Okay, many differences we have found. So can anyone tell me all the differences that we have? Available expression analysis and live variable analysis. What are the differences you have found? The first difference you can tell me. First difference you can notice that this is forward analysis. Can you notice? This is forward analysis. And can you notice that this is backward analysis? This is a backward analysis. I told you the definition of forward analysis. I told you the definition of backward analysis. You can notice that in this available expression analysis what happens, and in this live variable analysis what happens. You can notice here, okay, in this available expression analysis what happens, let me tell you. So you can notice that there is a statement. This is your statement N, and this is something called in of N, and this is out of N. And here also you have a statement N, there is something called in of N, and there is something called out of N. So can anyone tell me, okay, in this available expression analysis what we do? In this available expression analysis what we do? Here what we do? Here actually you can notice that this out is written in terms of in. This out is a function of in, correct or not? Yes or no? Yes or no? This out is a function of in. So this out, this will depend on this and this, these two things. It will depend on these two things, correct? This type of analysis is called forward analysis because out is a function of in. Here what happens? Here in is a function of out. Here in is a function of out. Correct? So that is the reason I told you forward analysis what it means and backward analysis what it means. Okay, forward analysis and backward analysis. What are the definitions? Focus on the definitions of forward analysis and backward analysis. Backward analysis. What are the definitions? The definitions are these. Okay, remember you have something. Let's assume you have some statement S, and this is your in, and this is your out. And now forward analysis means that this out is function of in. That this out is function of in. Okay, so this out should depend on these two things. Means this out should be calculated from this and this. Okay, so this is your. And this function, what is the name of this function? What is the name of this function? This name of this function actually I told you transformation function, but it is called transfer function. Okay, so this is called transfer function. What is the backward analysis? Backward analysis is like this. You have in, you have out, and the backward analysis definition is this, that this in is found in terms of S comma out. Okay, so this in we found in terms of S comma out. So this in is dependent, this in is calculated from s comma out, these two things. So this is your forward analysis, this is your backward analysis. Okay, and in any situation, okay, this is called, so if this is your in and this is your out, okay, and this is your s, then in this situation you can notice this is something called transformation function. Okay, so you can notice this is your forward analysis. Okay, and you can notice this is called transformation function, means you are finding this out in terms of in comma s. Okay, and this function we call this function we call it transfer function. Anyway, the name is transfer function. Okay, so the name is transfer function, and there is something called backward analysis. Okay, and here what we do, this in is found in terms of out comma s, and this is known as transfer function. This is called transfer function. Okay, anyway, okay, so this is the first difference, that available expression analysis is forward analysis and live variable analysis is backward analysis. What is the second difference? The second difference, what is that? Available expression analysis and live variable analysis. The second difference is the equations. Yes or no? The equations change. You can notice the equations are changing. Here you can notice that what is out of n. Here you can notice what is out of n. That is what is out of n. That is in of n union what is generated by n minus what is killed by n. Correct? Okay. And what is in of n? That is your intersection of all the predecessors, intersection of out of all the predecessors, where p is a predecessor. Okay, here the equations will change. You can notice what is the equation of in. Tell me, what is the equation of in? That is your out of n. Do you remember the equation of in? That is your out of n minus def of n. Okay, union use of n. Correct? Yes or no? And what is out of n? Out of n is union of all the in of all the successors. So this is a successor. Okay, is it clear? All these points that I am telling you, are they clear to everyone? So these are the differences. And what is the third difference? The third difference is, you can notice, if you are coming from here, okay, in this you can notice, in this available expression analysis, in this live variable analysis, the another difference is this. You can notice, if you are coming from here, then what you do here? Tell me. You do here intersection. Yes or no? You will do intersection. And here what you do? Okay, for example, if you are, okay, if you have this, then what you do? You do union. So here you, what you do? Here you have something called, let's assume E1, let's assume E2, let's assume E3. Then what you will do here? At this point, what you will do? At this point you will do E1 intersection E2 intersection E3. Correct? Okay. And in this live variable analysis, what happens? In this live variable analysis, let us assume this is V1. Let us assume this is V1. And this is V2 and this is V3. Then what we do here at this point? At this point, what we do? Okay, so at this point, what we do? At this point, we do V1 union V2 union V3. So this is another difference, yes or no? So this is another difference. I hope all these points are clear. So every point we have seen. And you can notice another difference. Let me just quickly tell you available expression analysis and what is live variable analysis. If you have this statement, let us assume you have statement n, and that is a equal to b plus c, and here you have a equal to b plus c. Tell me what is generated by n in this available expression analysis. What is generated by n? That is b plus c. This is generated by n. And what is killed by n? What is killed by n? Any expression containing a. Yes or no? Any expression containing a. Correct or not? Containing a. Any expression that contains a. Tell me what is generated. here what is generated here? Generated means use. I told you generated means use. So what are generated here? B comma C, these variables. Okay, and you can notice what is killed here. Killed means deaf. Killed means deaf. What is killed here? A is killed. Okay, agree? So this is how, these are the some differences. Okay, another difference is this talks about this talks about expression. This talks about expressions. Okay, expressions that are computed expressions. Computed expressions. And this talks about variables. Talks about variables that will be used in future. That may be used in future. Okay, so all the differences we have seen, I hope all the differences are clear to everyone. Okay, I don't think any difference I have left out. Okay, so all the differences that are there I have told you. You can just check it out. Okay, so these are the differences you can notice. Okay, so like this you can do. Anyone has any doubt? Now we will see again common sub-expression elimination. Just let's take one example. Okay, so this common sub-expression analysis, this common sub-expression elimination we can do using available expression analysis. Okay, so for example you can notice here. Okay, just think about it and tell me. Okay, this is your statement. When you are here, what you will do? Just tell me. Just tell me this point. What you will do here when you are here? Okay, when you are here at this statement, what you will do? You will compute A into B, right? Yes or no? So this statement computes A into B, correct? This statement computes A into B, correct or not? This statement will compute A into B. This will also compute A into B plus C. Okay, so both these are computed. You will compute A into B. You will also compute, let us assume you put it in T, let us assume you will put it in T, then it will also compute T plus C. Correct or not? So this statement will compute A plus B, A into B. Okay, and this will be put in a variable, and now you will also compute T plus C. Okay, so this is the point. Now finally here A plus B, A into B is available. Okay, here A into B is available. Correct. Now similarly you can notice here. Again I was telling you what compiler actually does. Okay, I told you what compiler actually does. See, here also y into z is available, here also y into z is available, here also y into z is computed. Okay, whether you come from this path, y into z is computed. If you come from this path, y into z is computed. If you go like this, y into z is computed. Now what should I do? Okay, at this point what should I do? So actually it is like this. So it is actually y into z. So what you can say, it is into y into z. So what should I put here? This is the question. Y into z, what should I put here? Okay, so this y into z is available, but what should I put here? Can anyone tell me? What should I put here? Should I put A? Should I put B? Should I put C? This is my question. Can anyone tell me? Should I put A, B or C? What should I put? Should I put A? Should I put B? Should I put C? What should I do? So the answer is very simple. I told you what compiler will do. So what compiler will do? Compiler will create a new variable. You can notice, okay, you can notice we can eliminate a common sub-expression by storing its value in a new temporary variable. This is very important. Okay, this is very important. We can eliminate, if you want to eliminate a common sub-expression, okay, you can eliminate a common sub-expression by storing its value in a new temporary variable when it is first computed, and then reusing that variable later when the same value is required. Okay, so this is very important. So what your compiler will actually do, let me tell you. Okay, so the compiler will actually, okay, will store, okay, if you are coming by this path, then what compiler will do? If you are coming by this path, then what compiler will actually do? So compiler will actually do like this. So it will compute and it will put t equal to y into z. Okay, here also it will do t equal to y into z. Here also it will do t equal to y into z. Okay, and then what you will do, then this compiler will remove this, remove this, and it will put t here, t here, t here, and then what it will do, then it will remove this, then this also will be removed, and then it will be put, okay, this will be replaced with the t. Okay, so this will be actually replaced with t. So this is the whole point. I hope this point is clear to everyone. So read this. We can eliminate a common subexpression by storing its value in a new temporary variable when it is first computed, and reusing that variable whenever it is required. Okay, so you can notice this is the point, and this is the algorithm. What you do for a node n, okay, which computes an already available expression e, what you do, you replace this e with a new variable t. Okay, and then what you do, you go backwards and you replace, okay, find the first instruction which is calculating e, and what you do, add a new instruction to store its value into t. Okay, so this algorithm actually you can understand by example. So let me take example, and this algorithm you can very easily understand. Okay, so let's take this example. Consider this example. What will happen here? What your algorithm will do? This is what your algorithm is going to do. Okay, so this is what your algorithm is going to do. Sorry. So what your algorithm is going to do, let me tell you. Remember, okay, what your algorithm is going to do, this is what I am telling you. So you can notice your algorithm is going to do like this. Here y into z is available. You know y into z is available. Why? Because y into z is coming from here, y into z is coming from here, y into z is coming from here. You know y into z is available because you can notice here y into z is coming. Here also y into z is coming. Here also y into z is coming. So you will take intersection, correct? You will take an intersection, correct or not? So here you will take intersection. So when you take the intersection, then y into z is available. Now here y into z is available. That is fine. That is very good. There is no problem. Okay, very good, very good. Now you can notice your algorithm is going to do like this. Read this algorithm. Read this algorithm one time. Okay, let me explain this algorithm. This algorithm is saying if you are at a node n which is computing already computed expression. So this is the point. Okay, let us assume you are at n. So you are here, and let us assume it is computing e. Let us assume it is computing e. So let's assume this is computing expression e. Then what you do, and let us assume you know that e is already available. So here e is already available, means I am saying that e is already available, means e is coming from here, e is coming from here, e is coming from here. So I can say that here e is available. I can say e is available here because e is coming from here, e is coming from here, e is coming from here. Then what your algorithm will do? So you are at a node n, you are here, okay. Here you are computing an already computed expression. Then what you do? This is what you need to do. Then what you do? Very simple. Then this e you replace with t. Okay, so for example, this is your n, and let's assume something like this you are doing. Okay, then what you do? This e you replace with t. This e you replace with t, and then you go backwards. So you can notice, okay, what to do on each path, you go backward, and then you find the first instruction which is calculating e. So you go here, okay, you backward you go, you backward you go, you backward you go, and you find where e is computed, first. Okay, so let us assume here e is computed. Okay, let us assume here you are computing e. So let's assume d equal to e. Okay, and let us assume here also you are computing, let's assume c equal to e, and let's assume here a equal to e. Then what to do? You go backwards and find where e is computed. Now once you find this e, that e is computed here, okay, then what to do? Then very simple, this e you put in t, so this t, okay, so this e you put in t, so you just put this e in t and you replace this with t. You put this e in t, okay, and then you replace this with t. You replace this e in t, okay, and you replace this with t. Okay, so this is what you need to do. Is this algorithm clear to everyone? Is this algorithm clear? So the algorithm is very simple. So here you can notice on this path y into z is available, on this path y into z is available, on this path y into z is available. Now you are here, okay, you are standing here, okay. Now you know that y into z is available. Now you are computing it again. So what you will do? You will replace this y into z with t. So this y into z you will replace with t. Now you will go back, okay, and whenever you find this y into z is computed, then what you will do? You will put this y into z in the temporary variable, and then you will you will do this. Okay, so this is your algorithm. I hope this algorithm is clear to everyone. If anyone has any doubt, let me know. Okay, is this clear? We are using T. There is no dead code elimination. Rahul, can you notice there is no dead code elimination here? See, just notice here. Here you are using this T. See, this T is not dead. Okay, here this T is not dead. Can you notice here this T is not dead because you are using this T. Rahul, is this point clear? There is no dead code elimination here. Rahul, let me know. You can notice here T is not dead because you are using T. You are using T because you are using T, so T is not dead. In the future you are using T. Okay, so I hope this algorithm is clear to everyone. Okay, so now what is the problem with this scenario? Can anyone tell me what is the problem? Anyone can tell me? Can anyone tell me if you do like this? This is the algorithm for common subexpression analysis, elimination. Okay, so this is the algorithm. We have seen the algorithm. This is the algorithm for common subexpression elimination. For common subexpression elimination. Okay, so this is your algorithm. But from this algorithm, can you find something like something is not good? Like, can you find some problem? Can you find some disadvantage? This is what I am asking. Can you find some disadvantage? Let me tell you the disadvantage. First of all, the disadvantage is your code is becoming large. Okay, you are getting more variables. So you can notice these are the disadvantages. Okay, this is the algorithm for common subexpression elimination, and the disadvantage I am telling you, and the disadvantage are this. Because you can notice you have 3 register copy instructions have been generated. Okay, so these new instructions have been generated. 3, okay, this instruction, this instruction, this instruction, new instructions have been generated. Okay, because these new instructions have been generated, so the program is larger. First of all, your program has gotten bigger. Initially your program was very simple. This was your program. Now your program has gotten larger. Okay, so you can notice and you can also notice that your program has gotten larger. Now, has it become slow or fast? It will depend on the architecture. Okay, whether this program has become slow or whether it has become fast, that will depend on the target architecture. So this is also important. So remember, don't think that common subexpression analysis, common subexpression elimination will speed up your processor, will speed up your program. It is not necessary. Most of the time it will happen that when you eliminate common subexpressions, then your program will become faster, but it is not necessary. Why? Because your program is getting bigger. Your program has gotten bigger, and you can notice many register copy instructions are there. These are the register copy instructions. Okay, so that is the reason whether it is faster or not, that will depend on the target architecture. Okay, so this is the point. Anyway, let us see. This is your GATE to 2021 question. Can you solve it? Can you solve it? Okay, so this is a very simple question actually. Again, this is common subexpression elimination. The question is saying that you have done common subexpression elimination on this code. Okay, so let us see where can we do common subexpression elimination. Let us see. You can notice that. Okay, let's see this question. Very simple. First of all, you notice this first line. Okay, you notice this first line. What is this first line? This first statement is saying that z equal to x plus 3, okay, plus x plus 3 plus y, okay, plus y, okay, f. Okay, so this is your first instruction. Now you can notice. Okay, so first of all, the question, you can read the question. Okay, you can read the question. Common subexpression elimination you have done. Now you can notice in this statement what your processor will do. Just tell me what your processor is going, what your compiler is going to do. Tell me what your compiler will do for this statement. Just tell me what compiler will do. Tell me what compiler will do. What compiler will do? Can anyone tell me what compiler is going to do? Compiler is going to do what? After this statement, what are the available expressions? Just find it. Okay, after this statement, what are the available expressions? So tell me After this statement, what are the available expression? This is your statement n. So let's call it statement n. Okay. Whatever you are computing here, that you will not compute again. So what is this out of n? So can anyone tell me, like, what are the available expression? What are the basically what are the I can say what are the generated by n? This is the point. What are the generated by n? So which instructions are generated by n? Because for this instruction there is no predecessor. You can notice there is no predecessor. So what is in of n? That is 5. You already know. In of n is 5. Why? In of n is 5. Why? What is the reason? Because there is no predecessor. Yes or no? Since there is no predecessor. Because no predecessor. Correct or not? Okay. So that is the reason in is 5. Now what is out? Out is simply what? Out is, you know the equation for out. What is that? Equation for out is, okay, the killed. So there is nothing to kill here. So finally I can say that what are the available expressions? Just tell me this point. What expressions are available? Can anyone tell me? You can notice the expressions that are available are, so your compiler will compute x plus 3. So this x plus 3 will be computed. This also will be computed. Okay, yes or no? So this expression also will be computed. This also will be computed. All these things are computed. Actually this is also computed. X plus 3 plus this x plus 3 plus this is also computed. Okay, and this is also computed. All these things are actually computed. Okay, and so on. Some other things are computed. You can notice x plus 3 will be computed. This also will be computed. This also will be computed. You can notice this also will be computed. Okay, so all these things are computed. Actually this also will be computed. So like this. So these are the computed expressions. So here you have computed expressions. So I can say that, okay, and I told you computed expressions are put in the temporary variable. Yes or no? Computed expressions are put in the temporary variable. So create one temporary variable for x plus 3. Create one temporary variable for y. Okay, this okay, and create one temporary variable for this. Is this clear? Anyone has any doubt? Anyone? So you can notice this is what I am telling you. I am telling you every computed expression is put in a temporary variable. This is I told you. This I already told you. Okay, we know. This I already told you. We know every computed expression is put in a variable. Every computed expression. Okay, every computed expression when reused. Okay, every computed expression when reused is put in temporary variable. Okay, so because I told you the algorithm, do you remember the algorithm? Do you remember the algorithm? When you create temporary variable, this is the point. Okay, this is my question. When do you create temporary variable? When do you create temporary variable? Tell me. When do you create temporary variable for some expression? Tell me. For some expression. When do you create temporary variable for some expression? This is the question. Anyone? Do you remember the algorithm? I told you the algorithm. And the algorithm you already remember. Remember the algorithm. I told you that you are at here. Okay, you are at in this point. You are at this point. Okay, and I told you that if you are using this expression, so here you are using this expression using e. Okay, so you are using this expression e. Now you can notice here. Let us assume, okay, e is already available. Okay, so e is coming from here, e is coming from here, e is coming from here. Then what you will do? I told you that you will put it in t, and then you will go back and you will find where is this. For example, what you will do, you will replace this with t and you will do this. Correct or not? Do you agree? This is what you will do. This is what you will do. Okay, so I told you that we know every computed expression when reused is put in a temporary variable. Okay, so when do we create a temporary variable for some expression? when it is reused, yes or no? When, okay, so the answer is what? You know the algorithm. From the algorithm you can notice when reused, so whenever you are reusing, then what you do, you go back and you create a temporary variable, yes or no? So when reusing, we go back and create a temporary variable. When reusing an available expression, a computed expression, I can say, when reusing a computed expression, we go back and create a temporary variable. Okay, so anyway, let's come back to this point. Okay, so you already know all these things, all these small things I am telling you. So you can notice that, so so you can notice this is the point. These are the available expression, x plus 3y. Okay, so these are the available expression. So now you can notice we are using them. Can you notice we are using them? So because we are using them, so we are putting them in temporary variable. Remember why I am creating this temporary variable? Because we are using them, we are again using them. Can you notice here? You can notice, actually you should ask this question, why I am creating these temporary variables? Because why I am creating these temporary variables? Because you can notice we are reusing them. You can notice x plus 3 we are reusing, this we are reusing, this we are reusing, this we are reusing. Okay, so finally what program I will get? So from this what I am going to get? Can you notice? You can notice nothing is changing, only I is changing. I, pq comma I, these are changing. Okay, so you can notice x, y, f1, f2, these are not changing. Okay, because pq, only these things are changing. So here you can notice, here one thing you can notice here, very important thing that you can notice here, what you can notice that, okay, x comma y comma f1 comma f2 comma x, y, f1, f2 not changing. Okay, x, y, f1, f2 not changing, correct? Only, okay, only pq, okay, so you can notice pq, I are changing. So here you can notice only pq comma I are changing, pq, I change. Okay, so what you can do here, very simple, you can remove this x plus 3 you can remove, and you can, okay, what you can do, this x plus 3, this you can remove. So let me remove this x plus 3, and this x plus 3 also you can remove. And what you can do, you can put this t1 here, this t1 you can put here. And similarly you can remove this yf1, this you can remove with the t2, this you can remove with the t2. So this yf2 you can remove with the t2. Okay, you don't have to compute it again, this t2. Okay, so that's it. Now finally the question is asking how many additions and how many operations are there, how many addition operations are there, and how many these operations are there, dereference operations are there. So you can notice there is no only the dereference operations are this. So only two dereference operations we have, because there is no dereference operation here. You can notice there is no, now you can notice there is no dereference operation, because, okay, so the only number of dereference operation is only 2. Okay, so the answer is definitely this number of dereference operation is definitely 2. And how many additions are there? Number of additions. This loop is running how many times? 100 times. This loop is running 100 times. Okay, and you can notice each time this addition is done, each time 100 times loop is running, and this addition is done every time. So what we can say here, I can say that, okay, I can say this I plus 2, this is done how many times? Okay, this is done 100 times. Okay, so this I plus 2, every time you are increasing. So this addition, this is addition. So this addition, I can say this is your addition, because you can notice. Okay, so let me write it. I am talking about additions now. So you can notice that this I plus 2, this addition is done 100 times. And what else? Now you can notice there is a if loop. So okay, either this will run or this will run. In every iteration, either this will run or this will run in any iteration. Yes or no? So I can say in any iteration I, okay, I can say that either if will run or else will run. So you can notice 100 times. Okay, so this loop is running 100 times, and 100. Okay, every time two addition are there. So in every iteration two addition. So in every iteration, what I can say, in every iteration we have two addition. So finally, what I can say, so 200 additions. So 200 additions. Okay, so the final answer will be what? 100 additions here, 200 additions here, and one addition here. Okay, three additions here actually, because z is equal to what? Z is equal to t1 plus t2 plus t3. Z is equal to t1 plus t2 plus t3. So I can say three additions. Okay, two additions here, and so okay, so I can say this is single. Now finally I can say t1 is equal to x plus 3. So this is one addition. I can say this is one addition, and similarly z is equal to t1 plus t2 plus t3. These are two addition. So total additions how many? Total additions how many? 100 plus 200 plus 3. Okay, these are 100, 4 I plus 2. Okay, these 4 additions inside loop. Okay, inside body. Okay, so I can say for you already know. Okay, so these outside the loop, before loop. Okay, so the answer is 2. Okay, so that is answer is this. Okay, 303,2. So the answer is option D. Is it clear? What if we use an expression only once? Okay, then there is no need, because remember one thing you should remember, that if you do this common subexpression analysis elimination, then program size will increase. Okay, a lot of copy instruction will be there. Okay, so that is the reason we don't, when we reuse, then we create a new variable. So this is the point I want to tell you. You can notice here, when we create a new variable, this you can notice. Okay, so this question you can notice. When do we create a new variable? When we create a temporary variable for some expression, when we are reusing it. Okay, because remember, when we eliminate the common subexpression, then okay, so you can note this. Okay, when we do common subexpression elimination, then what will happen? When we do this, then what will happen? Then program size gets bigger. Gets larger. Okay, so sometimes. Okay, so this can happen sometimes. I can say when we do common subexpression elimination, then sometimes what will happen? Then sometimes program size will get larger. Second, a lot of temporary variables will be there. A lot of temporary variables. Second, third point, a lot of register copy instructions. So all these things we don't want actually. All these things. So that is the reason we should take care. Okay, so when we reuse some expression, when we reuse some already computed expression, when we reuse, remember, when we reuse already computed expression, then we go back and create temporary variable to store that expression. This is what our algorithm has done. Did you see? This is the algorithm. Okay, if there is an expression in, okay, then we will have only one temporary variable, as compiler will create temporary variable this expression as well. Okay, or will it be t1 plus t2? No, compiler, we have already taken this example. Do you remember? See, this example we have taken. For example, I told you, let us assume a is equal to b plus c plus d. Okay, and let us assume you have here something called e equal to b plus c plus f. Then what? Okay, what your compiler will do? So okay, let's assume this is your program. Now what your compiler will do? So the compiler is going to do like this. Here what are the expressions available? So b plus c is available. You know b plus c is available because compiler has computed. So b plus c is available. This b plus c plus d is also available. Okay, so this is also available. I can say b plus c plus d. This is also available. Okay, so this expression is also available, b plus c plus d. Okay, so these expressions, this b plus c is available, this b plus c plus d, this is available. Now you can notice what you are using here, you are using b plus c here. Okay, so basically we are reusing, I can say we are using already computed expression, Okay, so here you are reusing the already computed because this is already computed. Now what compiler will do? Now your compiler will go back and create. Okay, so now compiler will do like this. Compiler will replace this with the t. Okay, so this will be replaced with the t, or I can say so this will be replaced with the t plus f, and then it will go back and it will do like this. Here also it will put t. Okay, and then it will put d, and it will put this d. Okay, this b plus c. So like this your compiler will do. Okay, is it clear? So compiler will create temporary variable when you are reusing. Okay, another example you can take. For example, let's assume a equal to b plus c plus d plus e. Okay, let's assume this is the expression. Okay, and let's assume that you have something, I can say maybe e equal to b plus c. Now in this situation what your compiler will do? Again what your compiler will do? Again you can notice here what is live. So b plus c is computed, d plus e is computed, and you can notice b plus c plus d plus e. This is also computed. These expressions are computed. Now what your compiler is going to do, because you are reusing, I am reusing. Okay, already computed expression. Okay, so what your compiler will do? It will do like this, equal to t. And this b plus c, it will go back, and what it will do, it will go back and it will do like this. Okay, d plus e, and then what it will do, and then it will basically it will I can say, so this t equal to b plus c. Okay, so like this your compiler will do. So basically the common subexpression elimination algorithm will do like this. Is this clear? So like this because we have already seen the algorithm. I told you this is the algorithm. Okay, you can notice here this algorithm we have already seen, correct? So this I told you can notice here. So you can notice this algorithm. Okay, this algorithm actually does this: find a node n which is reusing already computed expression. Okay, so which is computing already computed expression. Then what to do? Then you create a variable, and then you go back and you create variables. Okay, basically this is what you need to do. I hope this question is clear to everyone. So this is your GATE exam question, and in this question you only have to do common subexpression elimination. So this is how you can do. Okay, Nafiz, is your doubt clear? Nafiz, let me know, is your doubt clear? Okay, so like this you can do. So basically we have seen all these points. So like this you can basically solve this GATE question. Okay, anyway. Okay, here actually I want to stress one more thing here. Basically, remember this point that if you do liveness analysis together, okay, so this I told you, okay, if you do, okay, so this in the liveness analysis I told you what is dead code elimination, how to do dead code elimination, what is the best way if you want to do dead code elimination. Okay, two ways. Okay, what is way one? Way one is first you do liveness analysis. Okay, so this analysis you do, and then you do dead code elimination. So this you have to repeat. Okay, so what is the problem with this? This we have, okay, what is the problem? The disadvantage. What is the disadvantage? May have to repeat many times. May have to repeat many times. Okay, and what is way two? Way two is combined algorithm. Yes or no? Combined algorithm. combined algorithm. Okay, what this combined algorithm will do? So this liveness analysis plus dead code elimination, you do together simultaneously, you do this. Okay, let me take one example here. So first let me do wave 1. Okay, do dead code elimination using wave 1, okay, so let us check it out. Using wave 1, what you are going to do? So first to do liveness analysis. So this is the liveness analysis, you can notice. Okay, so here you will get Z, and then here you will get ABZ, and then here you will get AYZ, here you will get XYZ. So this is your analysis. Now after this analysis, what you do? So after this analysis, what you will do? Tell me. Then you will, this C is dead, because you can notice you are not using this C. So this C is dead. So you can remove this. Now, is it enough? Tell me, is it enough? Can I stop here? So first I have done liveness analysis. Now can I stop here? So this we have done actually. You can notice this is liveness analysis. Can I stop here? This is your liveness analysis. Okay. Now what you have done? This is your dead code elimination 1. So this is liveness analysis 1, and this is dead code elimination 1. Now can I stop here? No, I cannot stop here. I cannot stop here, because what you have to do now, because this is gone, so now you again have to do the liveness analysis. Then again you have to do the liveness analysis. So what you do now, again do the liveness analysis. Okay, so this is the point. Now when you do the liveness analysis second time, then what will happen? Tell me. Liveness analysis 2. Tell me what will happen. If you do the liveness analysis again, then what will happen? This AB, now this AB is gone. Now this AB is gone, and from this what will happen? So this A is not there, YZ is there, and now you can notice. Okay, so YZ and okay, X. Okay, so this, now again you can notice, now this B, now okay, so this is your liveness analysis. Now you can remove this. Now this is dead. Now this is dead. So now you can remove this, and this is your dead code elimination 2. Correct? This is your dead code elimination 2. Can I stop here? Can I stop here? Again the answer is no. Again the answer is no, because this is gone. Okay. Now again what you have to do, okay, because this is gone. So what you have to do here? Now because this is gone, so now this Y is also gone. Okay, because this is gone, so this Y is also gone. So this Y is also gone. Okay, and okay, so now you can notice, now this can also be removed. Now we can remove this also. So basically many iterations you have to make. Okay, so using wave 1, you can notice many times repeat until no more dead code, until no more dead code. Okay, but if you do wave 2, using wave 2, what you can do? Tell me. Using combined algorithm, what you can do? That is very nice algorithm. Using combined algorithm, what you can do? Tell me. Very simple. Okay, so you can notice that. Okay, so let's assume this is here. Okay, because this we are printing Z. Okay, so don't remove Z. Okay, because we are printing Z, so don't remove Z. But anyway, you can remove this. Now when you remove this, now using the combined algorithm, you will not get this AB. Okay, so now you can remove this also. Now because you are removing this, so you will not get this A, you will not get this Y. Okay, so now you can remove this also. So finally here also you will not get X, you will not get Y. Okay, so this is how, using combined algorithm, only one pass. Okay, anyway, so that's enough for today. Now okay, so we can take a break actually. Okay, so I hope all the things are clear to everyone. Okay, so this is your available expression analysis. Okay, we have seen every variation, every type of questions we have done. We have seen liveness analysis. Okay, so both these things we have done, and we have done the gate exam questions. Okay, all the gate exam questions of liveness analysis, available expression analysis, common sub-expression elimination. Okay, constant propagation, copy propagation, constant folding, okay, strength reduction, all these topics, every topic we have already seen. Okay, so this is your constant folding, you already know. basically at the compile time you can compute. So these 2 plus 5 at the compile time you can do this. Okay, at the compile time you can write it as plus 5. This is called constant folding. Okay, anyway, so if anyone has any doubt you can let me know. Anyone has any doubt? So this is enough for today. Okay, and remember on 20 we have undecidability class. So this is a reminder, this is a reminder for all, that on 20th January, okay, on 20th January we have decidability class, we have decidability lecture. Okay, in this, after this lecture, I want to say that after this lecture you can solve all the gate exam questions very comfortably. Like basically you can solve almost, like I can say that 99% of the decidability questions you will be able to solve after this lecture. Okay, so on 20th January decidability lecture at 6 p.m. on Go Classes YouTube channel. Okay, so thank you everyone. If anyone has any doubt you can let me know. Okay, see you on 20th. See you tomorrow basically. Okay, any doubt? Anyone has any doubt? If anyone has any doubt you can send me your doubt on the WhatsApp. Okay, so you can take my WhatsApp number. So this 9468930964, this is my WhatsApp number. You can send me doubt on WhatsApp. Okay, so here you can send your doubts. Or in the Gate Overflow group also, you can, on the Gate Overflow Telegram group you can tag me and